Science and exploration go together. You just don't go somewhere to plant a flag. We've done that in the past. We don't do this anymore. We go somewhere because it's useful, because we're going to learn stuff. That's the way the world goes, and that's the way, you know, the world gets better, I think. We're doing science every day. That's our daily activities. When I'm not doing this, I think just floating. Floating is just unbelievable. It gives you so much freedom. You can spend your entire day just drifting down the modules and just relaxing. It's probably the best way you can relax.
There's a whole section of the research we do on ISS, which is human research. So clearly, the goal here is to help improve what's existing on Earth and then make new discoveries. So we look at different things. We look at bone, we look at muscle loss, we look at neurological research, how the brain of the astronaut gets rewired in a new environment. When we come back on the ground, the scientists can study how we rewired our brains, and then it gives them a better, let's say, map of the brain, which is poorly known, and then they can go see people who have had brain injuries, and then now they know where to look, they know how to improve their conditions. We have a huge study that we're carrying out right now. It's called Fluid Shift. It looks at vision changes related to human spaceflight in astronauts. Some of us experience a vision change during their spaceflight, and sometimes after. The results, when we get them, are going to apply to all the eye traumas in which the intracranial pressure is higher than it should be, and all that kind of eye trauma. And I'm hoping it's going to help people have a better eyesight.
One experiment I've had a lot of fun with is MARIS. Here, that big torture chair is going to help us understand muscle loss and muscle pathology on the Earth. So in medicine, lots of advances have been made thanks to the research we do here on the ISS.
And there are some critical technologies that we're also testing here on the ISS, how to grow plants in space, so that when we go deeper into space for further mission, Mars and further, we have this capacity of growing our own food and not be dependent on supplies from Earth. Aquapad, it's a new way of testing water for coliform bacteria and microbial life. It could be used in countries where access to clean water is sometimes problematic. We're trying to create new technology that's going to benefit the Earth. So it's interesting to know that the ISS flies over 90% of the inhabited land in the world every 24 hours. So it's a very good platform for Earth observation. We're trying to get the best images we can of different floodings or volcanic eruptions, landslides, things like this, and sending them down, and they're being used to assess the situation and to coordinate the support and the relief effort.
To maintain the space station, we have to develop technology, and this technology stems into society and is used everywhere, in aerospace, in cars, in home appliances, and there's a humongous list of applications that come from space. We've been building the station for 10 years and operating the station full speed only for maybe 3 or 4 years right now, so I expect many more good outcomes in the future. I think by doing this and by putting our lives in a balance, because it's risky to come here and to work here, we're preparing the next steps of human exploration, and we're kind of fostering this process, this ongoing process of exploration. I consider myself an explorer, maybe not as much as some other people, but it doesn't matter. It has to be there somewhere in the back of my head that we're not only doing science, we're also doing exploration, and we'll continue to do so, and we go to some other places in the future.